Hello everyone, so now we'll be looking at some past questions to see how to apply some of the concepts we've learned to solve differentiation questions. So let's get started. In this first example, we are told that if y is equals to 4x cubed minus 2x squared plus x, we should find the y over the x. So this is pretty straightforward. So we have y is equals to 4x cubed minus 2x squared plus x. So now if you remember our discussion or differentiation of algebraic expressions, what we have to do is just to differentiate each of these terms individually and add them together. So what does that become? So dy over dx will be equals to, when we differentiate 4x cubed, we bring this 3 down here. So we have 4 times 3, which gives us 12x. Then our power will reduce by 1. So that becomes 3 minus 1, and that gives us 2. So we have minus, we bring this 2 down here. So we have 2 times 2, which gives us 4. Then we have x, and our power is reduced by 1. So 2 minus 1 gives us 1. So here is to the power of 1. And when we differentiate x, what is the coefficient of x is 1. So this becomes just 1. So we have plus 1. So dy over dx is equals to 12x squared minus 4x plus 1, and that corresponds to option A, which is indeed the right answer. Let's move on to the next question. And here we are told to find the derivative of y is equals to x raised power 7 minus x raised power 5 over x raised power 4. So what comes to mind initially? So what comes to mind normally is to try to use the quotient rule. And if you use the quotient rule, you are still going to get the same answer, but it's going to be a very long and tedious process. But there's a better way to do this, and I'm going to explain that right away. So now let's imagine I give you this expression to solve. I said you should try to simplify 8 plus 4 over 2. What would you do? You will add these numerators together. So 8 plus 4 gives you 12, and divide by 2, and that gives you 6. But there is another way in which you can write this expression. 8 plus 4 over 2, you can also write it as 8 over 2 plus 4 over 2. So what have I done? I've splitted the denominator to both of the numerator. And when you solve this, 8 divided by 2 gives you 4. And 4 divided by 2 gives you 2. 4 plus 2 gives you 6, which is the same answer we got when we solved directly. So that means we can write this expression like this. So y becomes, we can split the denominator between the two numerators, and that becomes x raised power 7 over x raised power 4 minus x raised power 5 over x raised power 4. So if you remember from our law of indices, when you have division and you have the same base, in this case x, what you do to the power is that you subtract them. So this becomes x into bracket 7 minus 4, then minus x raised power 5 minus 4, which simplifies further to x raised power 3 minus x raised power 1, which is the same as x. So now I can easily differentiate this expression. So dy over dx will be equals to, I bring this 3 down, so I have 3x, and my power I reduce by 1. So 3 minus 1 gives me 2. And when I differentiate x, I just get 1. So I'm left with what? 3x squared minus 1. So as you can see, this is a very straightforward and simpler approach to follow, and that makes our correct option C. So what I want you to do now is to try to solve this using the quotient rule. And if you remember the quotient, if you don't remember the quotient rule, you try to look it up and see if you get the same answer. If you've solved this correctly, you should get the same answer, but you'll find out that it is a more elongated process and time consuming. So now let's move on to the next question. And here we are told to differentiate x squared minus 1 over x all squared. So what can we do about this? So the best way to approach this is to try to expand this expression. And if you remember, when I was talking about expansion, I told you that if you have something of the form a minus b squared, it's the same thing as having the first term and squaring it. So this is the same as having x squared, then minus, then you multiply this by this by this. So 2 times a times minus b gives us minus 2ab. Then you square the last term. So minus b squared gives you what? Plus b squared. So we can apply the same approach here. So what do? I first square the first term. So this becomes x squared all squared. Then I multiply this by this by this. Then I have plus open bracket x squared times minus 1 over x, then times 2. Then finally I square my last term plus minus 1 over x squared. So when you solve this, what does this become? This becomes x raised to power 4, then plus this x here cancels this square here. So I'm left with x times minus 2 times minus 1 times 2, which gives me minus x. So this becomes x raised to power 4 minus x minus 2x rather, and this becomes minus 1 over x squared. So this becomes minus 1 squared is 1, so this becomes plus 1, and x squared is x squared. So I have plus 1 over x squared. So now I can say y is equals to this. So I can now try to differentiate it. So I can write this also as x to the power of 4 minus 2x, and 1 over x squared becomes plus x to the power of minus 2 based on our law of indices. So I cannot differentiate this expression. So dy over dx. So when I differentiate x to the power of 4, I bring down my 4. So I have 4x, and I reduce the power by 1. So 4 minus 1 gives me 3. So now here I have minus 2x. Since I have only x here, differentiation of minus 2x becomes only the coefficient, and in this case that reduces to minus 2. So this becomes minus 2. And in this case I bring this minus 2 down. So this becomes minus 2x, and I minus 1 from the power. So minus 2 minus 1 gives me minus 3. So I can write it out properly as dy over dx is equals to 4x cubed, then minus 2, then minus 2 over x cubed. So now which option corresponds to that? If you look at that carefully, so that corresponds to option C. So this is the answer to the question. You should note also that this can also be solved using the chain rule, but that will be a longer approach. And what you do in that case is that you equate what is inside this bracket to u, then you try to apply the chain rule that I've done before. So as an exercise, I want you to try to solve this question using the chain rule. So now let's move on to the next question. So here we are told to find the derivative of sine theta over cos theta. Now this is a very tricky and funny and at the same time straightforward question. So what would you be tempted to do normally? Normally you would want to apply the quotient rule, and you should take note that when you apply the quotient rule, you will still get the same answer, but there is a far quicker and easier way to go about this. So now if you remember our discussion on trigonometric ratios that we've talked about before, we said that tan theta is the same thing as having sine theta over cos theta. So this expression is just a glorified way or another way of writing tan theta. So this is the same as saying find the derivative of tan theta. So now based on the differentiation of trigonometric functions, what I asked you to memorize earlier, you will recall that when you differentiate tan theta, you're going to get sec square theta. So d over d theta of tan theta, that means when you differentiate tan theta, is equals to sec square theta, and that makes the correct option to this question option A. So you can see that this is pretty straightforward, but it requires a prior knowledge of trigonometric ratios. Now I want you to try to solve the same question using the quotient rule, and at the end of the day you are still going to arrive at the same answer if you solve it appropriately. So you find out that most of the time JAMB questions are very tricky, and they require you to have ideas of multiple fields, multiple subjects, and when you can apply them correctly, as we've done here applying the concept of trigonometric ratio, we saw that this is equals to tan x, and this gave our answer right away as sec square theta, which drastically reduced the time that it took us to attempt this question. So now let's move on to the next question, and here we are told to differentiate sin x minus x cos x. So this is like normal differentiation, trigonometric differentiation that you are familiar with. So we are told to differentiate. So we are told to find d over dx of sin x minus x cos x. So now I'm going to take each of those terms individually. So now let's try to differentiate sin x. If you remember from our trigonometric function, when you differentiate sin x, what are you going to get? You are going to get what? Cos x. How about this term? Let's try to differentiate x cos x. So when you differentiate x cos x, what do you get? As you can see, this is a classic product rule application because we have two terms that contain x. You have x here and you have cos x. So based on the product rule, I take my first term in this case, which is x, and I multiply it by the differential of the second term. When I differentiate cos x, what am I going to get? I'm going to get minus sin x. Then I have plus. Then I take my second term in this case, which is cos x, and I multiply by the differential of the first term. And when I differentiate x, I get 1. So I multiply this by 1. So this becomes what? Minus x sin x, then plus cos x. So now I can substitute this value into these expressions over here. So this becomes differential of sin x becomes what? Cos x. Then I have minus, then the differential of x cos x I found to be what? Minus x sin x plus cos x. So what does that become? When I expand this, I have what? Cos x, then minus times minus becomes plus x sin x, and minus times plus becomes minus cos x. So cos x minus cos x cancels out, and I'm left with what? X sin x. So the correct option to this question is option B, x sin x. So now let's move on to the next question. And here we are told to find d over dx of this expression over here. This is a fancy way of saying differentiate cos into bracket 3x squared minus 2x. So let's write that. Let's assume that y is equals to cos into bracket 3x squared minus 2x. So this is a classic example of the chain rule. So to apply the chain rule, what do? I equate what is inside here to u. So I say let u be equals to 3x squared minus 2x. So now I can find du over dx. So du over dx becomes what? It becomes, I differentiate this with respect to x. So 2 comes, I have 3 times 2, which gives me 6. Then x is power 2 minus 1 gives me 1. The differential of 2x gives me 2. So now I can rewrite my y as being equals to what? Cos u. So dy over du, if I differentiate this with respect to u, what do I get? I get minus sin u. So now, based on our expression for chain rule, we said dy over dx, same thing as having dy over du times what? Times du over dx. So this becomes, at dy over du we found to be minus sin x, minus sin u rather, times our du over dx we found to be what? 6x minus 2. So now rewriting this, can write it as what? Minus open bracket 6x minus 2 times sin u, and my u is equals to 3x squared minus 2x. So I can replace that back, and I have dy over dx to be equals to minus 6x minus 2 then times sine, and the value of u is 3x squared minus 2x. So what option corresponds to this? If you look carefully, that corresponds to option D. So the correct answer to this question is option D. And to recap, we just apply the chain rule to solve this question. Now let's move on to the next. Here we are told that if y is equals to 3 cos 4x, dy over dx equals to what? So I told to differentiate this expression. So we have what? We have y is equals to 3 cos 4x. As you can see, this is another example again of the classic chain rule, and I'm going to solve this using the same, a shorter method which you should be familiar by now if you've practiced enough. So to solve this, we just differentiate this expression normally as if we had this as a single variable or a single term x. When I differentiate cos x, what do I get? I get minus sin x. So it becomes minus 3 sin what? 4x. Then I multiply it by the differential of 4x, and the differential of 4x gives me 4. So 4 times minus 3 gives me what? minus 12, then I have sine 4x. This is just a shorter way, or the same thing as applying the chain rule, but because I'm so familiar with solving the chain rule, I know how to go about this directly. So what I did again was that, remember that I would have made u to be equals to 4x. If I'm solving with chain, I would have said let u be equals to 4x, and I would have found du over dx, which would have been equals to 4. Now my y will now be equals to 3 cos u, and my dy over du would have been equals to what? Minus 3 sin u. So my dy over dx will just be multiplication of my dy over du, which is minus 3 sin u, times my du over dx, which is 4, which equals to minus 12 sin u, and u is equals to 4x, so it becomes minus 12 sin 4x. So you can see which is the same result, just that I solved it directly. And with solving JAMB questions, nobody is interested in seeing your working, so you don't need to work so orderly. If you're able to solve and do all these things with your head, then you can just easily write out the expression and simplify it, because speed is really important when you're trying to tackle JAMB questions. So now let's move on to the last question that I'll be trying to solve. And in this question, we are told to differentiate sin q minus cos q minus sin q all squared with respect to q. So what I'm going to do first is I'm going to try to expand this, and if you remember, like I explained in the previous 3 or 4 examples, I said when you have something like a minus b squared, same as having a squared minus 2ab then plus b squared. So I can apply that to expand this expression. So when I expand this expression, I have what? I have cos squared q, which is same thing as cos q all squared. Then I have minus 2 times this, which is equal to minus 2 cos q sin q. Then this becomes plus, and this becomes what? Sin squared q. Now if you remember from our discussion of trigonometric ratio, we said that cos squared q plus sin squared q is equals to 1. It can be x, y, z, whatever is here is equals to 1 when I'm multiplying sin squared of variable plus sin squared of the same variable will always equals to 1. So this plus this is the same thing as having 1. So I can replace that, so that becomes what? 1 minus 2 cos q sin q. So now what we want to do is we want to try to differentiate this expression. So I'll just say let y be equals to what we have over here. So now how do we go about this? If you remember from our discussion of trigonometric ratio, also we said that when you have something like what? Sin theta plus theta, which is the same thing as sin 2 theta, is going to be equals to what? 2 sin theta cos theta. So similarly, I can write 2 cos q sin q is the same thing as having what? Same thing as having sin 2q. So I can substitute that into this expression there. So I have what? Y is equals to 1 minus sin 2q. So now that I've gotten this to be sin 2q, I can now try to differentiate this. So to differentiate this, I now have the y over the x, the q in this case, because I'm differentiating with respect to q, will be equals to what? When I differentiate 1, I have 0. I'm left with minus sin 2q. So what do I have to do? I need to apply the chain rule also, because I have 2q here. So the same way I differentiate this normally. When I differentiate sin 2q, I get sin q, I get cos q. So this becomes minus cos 2q, and I differentiate what is inside here, 2q. When I differentiate 2q, I get 2. So that becomes what? So dy over dq becomes what? Becomes minus 2 cos 2q. And that makes the correct option A. So you can, as you can see, trying to solve or attempt the question requires a thorough understanding of trigonometric equation, and this is what I mean when I say that most of the questions or some particular questions in JAMB are interdependent. So not knowing trigonometric equation might hinder you from trying attempting this question, even though you know how to differentiate. You may not be able to solve it because you don't know how to apply trigonometric identity. So that is why you need to know how to apply all the concepts. I need to have a good understanding of the concepts so you know how to apply them even and draw inferences from other topics to other questions. So that pretty much sums up our discussion on differentiation. So what I want you to do now is to go through your past question and try to look for more questions to see if you can attempt them. And if you cannot attempt them, you can always make use of the forum so that you can learn from fellow students also. So that will be all for now. Bye.